Measures of central tendency for ungrouped data. There are two learning competencies. First, we'll focus on how to calculate the mean, median, and mode for ungrouped data. Summarize data with a single value. Next, we'll explore how to compare these measures to see what they tell us about the data. What is ungrouped data? Ungrouped data is a collection of individual data values that are not organized into intervals or classes. For example, consider the numbers 6, 8, 4, 8, and 11. These are raw data values listed one after the other. When we talk about a measure of central tendency, we're really discussing a way to find a single, central value that best represents a set of data. The three main measures we use for this are the mean, median, and mode. These measures are useful because they allow us to make meaningful comparisons. Whether you're evaluating test scores, tracking daily expenses, or analyzing survey results, these central tendencies give a clear snapshot of the data's behavior. To find the mean, begin by adding all the values in the dataset. Next, divide this total by the number of values in the set. In mathematical terms, the sum of all data is represented as the Greek letter sigma, and n is used to denote the total number of data points. Practical application of calculating the mean. To solve example 1, first, add the numbers together. 6 plus 8 plus 4 plus 8 plus 11. This gives us a total of 37. Now, divide 37 by the number of values in the set, which is 5. So, the mean is 7.4. Moving on to example 2, where we have the ages of 6 students. Again, start by adding these numbers. 13 plus 14 plus 15 plus 13 plus 16 plus 15. This totals 86. Since there are 6 ages, we divide 86 by 6, which gives us a mean of approximately 14.33. When we talk about the median, we're referring to the middle value in a set of data that's been arranged in numerical order. Now, determining the median depends on whether your dataset has an odd or even number of values. For an odd number of values, the median is the exact middle value. However, with an even number of values, things are a bit different. Here, the median is found by averaging the two middle values. Let's find the median using some practical examples. Starting with example 1, we have the dataset 6, 8, 4, 8, and 11. To find the median, the first step is to arrange these numbers in ascending order, which gives us 4, 6, 8, 8, 11. Since we have an odd number of values here, the median is simply the middle number, which is 8. Now, let's move to example 2. Here, the ages of 6 students are 13, 14, 15, 13, 16, and 15. We again start by arranging these ages in order. 13, 13, 14, 15, 15, 16. This time, we have an even number of values, so we take the average of the two middle numbers, 14 and 15, to find the median, giving us 14.5. The mode refers to the value that appears most frequently in a dataset. Let's go over the special cases. Unimodal. This is when there is a single value that repeats most often. Bimodal. Here, two values appear with the same highest frequency. Multimodal. When there are more than two values that repeat most often, the dataset is considered multimodal. No mode. Sometimes, no number is repeated more than once. In this case, we say the dataset has no mode. How to find the mode? Take a look at example 1. We have a set of data, 6, 8, 4, 8, and 11. To find the mode, we first arrange the numbers in ascending order. 4, 6, 8, 8, 11. Here, you can see that the number 8 appears twice. Therefore, the mode of this set is 8. Let's move to example 2, where we have the ages of 6 students. 13, 14, 15, 13, 16, and 15. Again, arrange these in order. 13, 13, 14, 15, 15, 16. In this set, both 13 and 15 appear twice. This means the data is bimodal, having two modes, 13 and 15. When comparing and interpreting the mean, median, and mode, it's important to consider how these measures relate to each other in the dataset. The mean gives us the average, the median offers the middle value, and the mode tells us the most frequently occurring number. By understanding their positions, you can determine whether your data is balanced or being pulled by extremely high or low values. This example highlights how selecting the appropriate measure, mean, median, or mode, depends on the nature of your dataset. First, let's calculate the mean. Add up all the study hours, 3, 4, 5, 5, 6, 7, 7, 7, 9, 13. This totals 66. Divide by the number of students, which is 10, giving us a mean of 6.6 hours. Now, for the median, arrange the numbers in ascending order and find the middle value. Here, we have two middle numbers, 6 and 7. The average of these two numbers is 6.5, so the median is 6.5 hours. Finally, the mode is the number that appears most frequently. In our dataset, 7 appears 3 times, so the mode is 7 hours. Which measure best represents the typical study time? Given that 13 is an outlier, the median, at 6.5 hours, is most representative of the typical student study time because it isn't pulled by this high value. Remember, choosing the right measure helps in accurately interpreting your data, leading to more informed decisions. The mean is ideal when your data is consistent and free from extreme values. Consider using the median when your dataset includes extreme values. The mode comes into play when dealing with categorical or non-numeric data. It's the most frequently occurring value in your dataset, offering insight into what is most common or popular. Thank you for watching. Subscribe, like and share. Follow me for more learning videos.